Hello, hope you're having a great day. This is Mr. Roderick. We are in section 7.6 of your textbook. We're going to break this into 2 days. This is going to be day 1 today, function operations. You're going to learn the basics of the function operations. So we're going to be able to take two functions and add, subtract, multiply, divide. And then you'll also be able to compose functions. In other words, you're going to basically lay a function inside of another function. Okay, those are the two things you're going to be able to do by the end of the day. And let's go ahead and get started with our what do we need to know before we start here. Down here at the bottom, if you look, evaluate, right? We did evaluation back in chapter 2, which basically means substitute a value. So most like you have your little t-chart over here. You have x, y, and x is -3 in this case. We're saying g of -3. Use parentheses properly, use our order of operations properly, and this will be easy speasy for you. We got -3 squared is 9, times 2 is 18 here. We get -3 times -3, careful there, is 9 more, and plus 1 more gives me a total of 28. Okay, and what we're saying here is if you take this parabola here, this 2x squared minus 3x plus 1, and plug in -3 for x, you get 28 for y, right? We've evaluated, okay? So that's basically the only skill that you need really to get started, and let's go ahead and get going with this. There you see at the top your addition, subtraction, multiplication, division. And the two things you need to kind of look at here are the notation is going to be important here. Whether you write it f plus g of x or f of x plus g of x, they're the same thing. And that holds for all four operations, major operations. Okay. Now with the multiplication, be careful. This is a little dot here, right? It's a little dot. And the reason this is important to note is when we do composition, you're going to have a little open circle as your notation right here. So for example, f circle g of x means compose the functions, lay one inside another, whereas this just means go ahead and multiply them. Okay? Get this guy out of the way for now. Talk about him more later. And now, down here at the bottom, right here, whoa, why'd that do that? We are going to talk a little bit about domains today, possibilities for x. Okay. So possibilities for x, right here, g of x being 0 would be bad, right? So anytime we have 0 in the denominator, can't divide by that, so we got to make note of that in our domain discussion today, okay? So the first thing we're going to do is add and subtract, okay? So let's go ahead, and if I add these, let's just go with f of x plus g of x as our notation. Now I just need to plug them in. Plus the quantity of g of x, the whole thing. And in this case, we've done polynomials combining like terms and everything. We know that these, at this point, these parentheses don't mean a whole lot. So I'm just combining like terms. -2 and 5 is positive 3x, and 6 and -7 is -1. There are no domain errors. In other words, there's no issue with anything being 0 in the denominator because the denominator is 1 all the way across there, right? So now let's do subtraction. Still pretty easy for you. So we got minus 2x plus 6. Be careful though, minus quantity 5x minus 7. Okay. Now some of you, it's going to pay off for you to write this next step here, because this minus is like a -1 being distributed through here. And this is minus 5x and plus 7. Gives me a grand total of minus 7x and 13. there's your addition subtraction. Okay? Nothing too earth-shattering there. Okay? No, again, no domain issues. Domain for all the domain for both of these would be that x is all real. Any real number would go for x, and I could basically, I could get a new line here. I could chart this out. All right, let's go to multiplication division. Okay, this time I've got f of x times g of x. Excuse me. So we're plugging in here, and we go x squared plus 1 times x to the fourth minus 1. And we distribute or FOIL, and we get x to the sixth minus x squared plus x to the fourth minus 1. Rewrite it in standard form. In other words, order it correctly. And again, domain issues, there are none. This is my answer, and domain is all real. All right, now let's go ahead and do division. So f of x divided by g of x. And now we got something a little bit more fun here. We got, let's see, x squared plus 1 over x to the fourth minus 1. All right, now I got to look at the bottom, and you have to recognize at this point, we're expecting you to recognize that as a difference of squares here. Okay, so I've got x squared plus 1, I rewrite on top. And on the bottom, x squared plus 1 and x squared minus 1. You say, but Mr. Roderick, I got cancellation here. And you do. These cancel. Even though there's an addition sign there, those are complete pieces, if you will, that are separated by multiplication only here. That's perfectly fine to cancel there. But I need to put a 1 in my numerator. Don't forget that. Then on the bottom, now I've got this x squared minus 1, which becomes x plus 1 and x minus 1. Guess what? That's my answer, but I have to state something here. X, the domain is all real, except x cannot equal 1 or negative 1. Because if it did, I would have a problem. I would have 0 in my denominators. Okay? So that's the one, building on a lot of our old knowledge as far as what's going on with denominators. We don't want them to be bad. We don't want them to be 0. Okay? Let's go to the last guy here. Let's go to composition. We can add, subtract, we can multiply, divide. Now let's compose. In other words, lay a function inside a function. And notation is very important here, okay? So I'm going to start with, they're asking me G circle F, and I'm going to start with G circle F of X to start. Okay? And we need to know, well, what does that mean? They're asking us to take the G function and lay the F function inside of it. I always work, I always work from this guy is getting laid inside, and you work from left to right there. Okay? So now, well, this is G of, they gave us a number value here of 2. So this becomes G of F of 2. And at this point, I should just stop. Okay, I should, because now I need to know, well, what do I need to know next? I need to know the function value when x is 2. So let's go ahead and do that. So I take the f function and just put 2 in for x. 2 to the third, well, that's 8. All right, so f of 2 is 8. So now I'm going to work through g of f of 2. We go ahead and I'm just going to rewrite what I have there at the top there. Well, now I know that f of 2 is 8. So this becomes g of 8. And now I've just got a simple plug-in evaluation, and I've got 8 squared, parenthesis, 8 squared plus 7. So I've got 64 plus 7 is 71. And now you can compose functions, okay? Now also quickly realize here that you could do this the other way, f circle g of x, f composed with g of x, and you're going the other direction. So that is saying take g of x and lay it inside f. Okay? All right. So know we can both go in both directions here. I don't have any domain issues with this one. And at the end of the day here, what we've done is you can compose. You can basically you can add, subtract, multiply, divide two functions, and then you can compose two functions. In other words, you can lay one function inside of another. This is day 1 of our 7-6. We'll follow this up with day 2 tomorrow. Hope you're having a great day, and we'll talk to you soon.